Kouamo Mersimine Flore, working on functional genomics at CRE. I defended recently my Ph.D. in November 2022 under the title Functional Validation of the Role of glutathione s-transferase gene cluster in insecticide resistant on Anopheles funestus, major malaria vector in our country. So far, it was mostly to understand the role played by the glutathione s-transferase gene family in the insecticide resistance. By looking the level of expression of the GST across Africa, I also studied the impact of the expression and the presence of the allelic variation in insecticide resistance. So far, through the RNA sequencing, we sequenced the samples across Africa and discovered that the glutathione s-transferase was mostly expressed in West and Central Africa compared to Southern and East Africa, where the cytochrome P450 are the more overexpressed. Also, we realized by performing functional validation that when we knock down using an RNAi the gene expression on Anopheles field mosquitoes, the mosquito where we reduce the level of expression of the glutathione s-transferase was most susceptible to the insecticide, meaning that the overexpression of the glutathione s-transferase alone can confer resistance to insecticide. Also, we perform transgenic expression of the mutant and non-mutant allele of glutathione s-transferase GST3, GST4, and GST6 on Drosophila, and we try to expose Drosophila to insecticide, and after 24-hour exposure, we realized that the fly expressing the mutant allele was more resistant than the fly without the mutation. Also, by performing heterologous expression of the dose protein and also the metabolic assay, we realized that the glutathione s-transferase alone can metabolize DDT to DDE and also metabolize the pyrethroid as permethrin. At the end of this study, we can see that the presence of allelic variation and also the overexpression of glutathione s-transferase play a role on mosquitoes insecticide resistance. Also, by taking advantage of the tool detected by the Genomic collaborator in 2014, we realized that mosquitoes having the F119 glutathione s-transferase GST2 was able to survive in the presence of insecticide. Also, by genotype, the L119F mutation detected by Veron and collaborator in 2021 in Melon, Cameroon, we realized that mosquitoes having the F mutation have more ability to survive in the presence of permanent and permanent 2.0 than the mosquito without the mutation, meaning that the presence of such mutation can impact the tool that we use for the vector control. At the end of our study, we can say that glutathione s-transferase play a role on mosquito insecticide resistance, and we need to put in place a tool using the glutathione s-transferase GST3, GST4, and GST6 to better manage the insecticide resistance in the field.
Center for Research in Infectious Diseases.